And we'll take the reading right from here to begin with. Got a reading of 6.477 volts and 3.216 milliamps. Let's see how that checks out. 6.477 divided by 2.015, and I'm getting 3.2144, 3.216. So we are about 1.6, it'd be about 16 microamps higher in reading. So I'm really kind of coming to the conclusion that possibly this resistor is a little bit lower in value than 2.015, but okay, we're going to figure the tolerance out in a while. Let's go ahead and try raising up the current again. Take it right about there. All right, I'm getting a voltage reading of 19.5 to 6 and a current of 9.689. All right. I would have expected 9.690, and I've got 8.9, so we are 10 microamps higher than expected. I really think we're just about where we can't go much higher. Alright, so alright, we're going to take her here. We have, let's see. Alright, we've got a little stabilization here. We got 38.25 and we've got 18.971. Alright, let's see, 38.25 microvolts times 2.015. No, that's not right. Got to divide. All right, let's try it again. 38.26 divided by 2.015. And I should get a reading of 18.987. 987 would put me at 7. under by 20 microvolts. All right. Let's go ahead and just change range and keep that current reading. I'm afraid we're starting to exceed what I can handle here. Okay, we've got on the 200 milliamp scale, 64.16 and 31.81. All right, 64.16 divided by 2.015 would have given me 31.84, and we've got 31.80. So we are 40 microamps off on the particular reading. And then let's go ahead and try the last scale. We have a voltage of 68.79 and a current reading of 34.3, 68.79. Predicting 34.14, so we are 0.16 higher. And that would be 0.16 milliamps on this range. So okay, I'm going to go and crank this out on the computer, and we'll see just how we checked out here. Okay, we have a 10K 0.01% resistor in series now with power supply, and we are on the 200 microamp scale. We're reading 99.967 microamps, and so we're roughly half scale. And we're getting a voltage reading of 0.9985, and we're going to record that. .96. Okay, and then we're going to go up closer to full scale. All right. So I'm seeing 1.9925 and 1.9945, or 199.45. Okay. Let's go ahead and change range. And let's see. We're on the 2 mil scale. Let's go ahead and get to 1 milliamp. Okay, close enough. So I'm getting a reading of 9.995. I'm going to call it a 5, and we got 1.0011. Okay. And then let's try and take her up. Let's see, am I safe with this? 10K, I should be. I should be safe. I think we're safe to go ahead and go up to, we'll do 2. And we'll take it right here. Okay, so we have a reading of 19.013 and 1.9042. 1141. All right, 1141. We'll take it to that way. All right, and we're going to stop with that right now. Okay, the results using the 10K 0.01% resistor came in, and what I'm finding is that that 0.01% resistor really did the trick. In every case, and the 2 readings we had on the 200 microamp scale and the 2 readings we had on the 2 milliamp scale, all of them came in under 0.2%, which is the spec limit. In fact, on the 200 microamp scale, we were 0.11 was the maximum percent, and on the 2 milliamp scale, 0.16. So we did quite well. So apparently our resistor and its value has something to do with our problem. It may be the fact that it's such a low resistance, 2 ohms instead of 10,000 ohms, could very well be it. Could make the whole system more sensitive to the shunt difference. There's shunts in this meter. Perhaps the shunts are slightly different than we think. I don't know, but or maybe the measurement of the resistance wasn't as accurate as we had hoped. But we did read on the 2 ranges very accurately. So we'll take another look at the 20 and 200 if we can figure out a better way. Okay, we're finally taking a look at AC milliamps, and we're connected up to our signal generator that is feeding our signal into a series connected 10K resistor. We're reading the current through that resistor and then back out to the generator. That's a 0.01% tolerance on that resistor, so I feel pretty confident about the resistance value. And our voltmeter is on the bottom, reading our AC voltage across the resistor. And right now we are feeding in a 10 kilohertz signal, so this would be the highest speed signal that this system was meant to take. So at 10 kilohertz, we have 1.005 volts and a corresponding 0.102 milliamps. Okay, we're going to kick the voltage up now. And okay, now we have 10.024 volts and 1.0152 milliamps. Both of these readings were on the 2 milliamp scale, yeah. Alright, we're going to take her back down again. Okay, we're okay at a volt. We're going to go down range. This is on the I'm reading the voltage now on the 2 volt instead of the 20 volt range. Didn't change the range on here at all, so let's go ahead and do that now. Okay, there we go. So now we've got 200 microamps, full scale. We're reading 93.24, and we are on the 2 volt range, and we're reading 0.9207. So 0.9207 volts and 93.13 microamps. Okay. And let's go ahead to the 20 milliamp range, and we'll turn this up all the way. All right, we're on the 20 milliamp scale. We have 10.784 volts, 1.097 milliamps. Okay. If I went to the 200 milliamp scale, we got 1.26. 200 milliamp scale, 10.795 volts, and 1.26 milliamps. Okay, well, one of the things I'd point out here is that these displays are a good ½ inch in height, maybe even a little bit higher. Makes them unusual. There's not too many displays that are that large. I mean, you can see the size of my thumb there. That's a pretty good size display. Anyway, one of the things that's a little unusual about the unit is in the zeroing of the AC voltage and in the current. This thing gets down to the microvolt levels, and at that point, the way the circuit is designed, it's a true root mean square measurement unit. It literally takes the square of the measurement and then finds the square root of it. Anyway, in the process of doing that, the circuit does not fully zero. In the calibration process, it is zeroed, and then the same control is winds up being utilized in the calibration to the 1 volt level, and so therefore there is a small amount of offset that can't be helped. So I wanted you to be aware of that when you see it. It doesn't seem to affect the measurement at all. I would assume that if you tried to get down to the less than, well, this isn't the AC level, so that's not going to help, is it? Is it? There we go. So if you got down to the 0.23 millivolt level, so 230 volt, 230 microvolts, or less, maybe your readings wouldn't work, but above that, they seem to be quite accurate. And then similarly with the current range, there is always a small offset on the zero. In this case, it's 200 microamp range. We are reading 0.23 microamps. So 0.23 microamps, 2/10. So that little offset you can live with, but you might be wondering how come you can't zero that out. Well, that's just the way it is. It's circuit doesn't allow it. But we've gone through the entire calibration on it. The calibration of the DC voltmeter and the ohm meter was right within specifications. The ohm meter, as long as we were using the 10,000 0.01% resistor, we were really about 1/2 of what the specification rating was in most cases, well under the 0.2% error. And when we use the 2 ohm resistor, which is 2 ohms, I think it was 1%, but at any rate, there was a little more error there, but I can't tell if it was more the resistor or its value. But in any case, the error was quite small. We were, see if I can find it here. Yeah, when we measured the current using our 10K resistor at 0.01%, our percent difference in the end came to be within about 0.1 to 0.16 maximum. And the specification is 0.2 for DC. And then for the 20 milliamp range, where we had to go to the 2.015 ohm 1% resistor, our percent difference rose to about 0.6 to 0.8%. But I think that was as much a fault of the resistor as it was anything else. I believe if we could have gotten a 0.01% resistor for it, we would have been right in there. When we went to the AC milliamps, our specification says that we're within 1% on AC from 45 hertz to 10 kilohertz, and that's 1% plus or minus 15 digits. We didn't do the digits, but we were within 1.14, 15. The worst we had was 1.72, and that was at 20 milliamps. 1.49 was the second worst. The rest of them were 1.3 or less percent. And I submit that if you take the 15 digits off of the readings that we had, that you would be right in the 1% range. So I think we did very well with the calibration check of the unit, and I think you'd be very happy with it on a bench. I know I'm quite happy with it myself. If I didn't have enough of these things, I'd be keeping one. So along with this unit, you'll get a set of test leads, brand new test leads, and we have an instruction and calibration manual for the 179. It comes with theory, it comes with general information about it, calibration, types of adapters you can get for it, troubleshooting, and along with the 8.5 by 11 drawings, which can be a little bit hard to read. They're clear, but they're tiny. I've also blown up an 11 by 17 version of it, so it's a little bit easier to read. So you get a nice manual with it. And like I said, we have a set of test leads, brand new ones here. Brand new set of test leads. So it'll be all set. Happy bidding. Good luck.